this. This will be the last one for you to attempt on your own. Reading this fun fact first. Something actually cool about arc cosines. Because an angle in radians determines the arc of the same measure on a unit circle, the inverse cosine is sometimes called the arc cosine. So explaining a little bit the meaning of those names. All right, again, this is for you to attempt first. Explain the meaning of each expression, then calculate its value. Sine x, if x is a half degree. Sine inverse of x, if x equals a half. And sine x inverse, if x equals 1/2. I think there's actually a minor typo on this, so let's see if you can catch it before I go over it. Please pause the video and attempt this first. All right, so let's try each of these. Sine of x if x equals a half degree. Well, this makes sense because we know that inputs for sine could be angle measures. So sine of 1/2, I can actually compute this. It gives it to me in degree mode, so I'm going to make sure to change my mode to degree. Now I have sine of 0.5 or 1/2, so I get 0.0087, I'll round it to 0.09. This means that I have a 1/2 degree angle as my input of this function, and I have a length, a vertical distance to x-axis of 0.009. Okay, very small, but I can imagine that on the unit circle in this manner, right? I can't even draw it that small. It'll basically look like a straight line here, but imagine that's a half a degree, right? Where that angle theta is 1/2 of a degree. Then this length or distance right here for y is my sine of 1/2 degree. That's the meaning in part A. What about part B? In part B, it says sine inverse of x if x equals 1/2. And should it be a degree? It shouldn't. That's a typo. So let's fix that. Because we know that the inputs for sine of theta are lengths, right? Sine inverse gives me the angle whose sine is x. So that means when I compute this value, I'm looking for sine inverse. We can use two strategies from above. Sine inverse, I'm going to use this strategy since it's my preferred. Sine inverse, inverse sine of 0.5 equals 30. Does that make sense? I sure hope so. Inverse sine of 30, or excuse me, inverse sine of 1/2 equals 30. What is 30? And what if I changed it to a different mode? Remember, this is degree mode. What if I change it back to radian mode? Does that give me a different answer? Sine inverse of 0.5, 0.523, what could that be? Well, I told you you'd need your unit circle. Unit circle is really helpful to be having and using in this unit. So sine inverse of 0.5 is 30. It's not surprising because when I take a look at my unit circle, right, at this angle of, it's okay to mark up your unit circle, this is your tool. This is an angle of 30 degrees. Well, I also know that that angle is what, pi sixths? I wonder, is pi 6 0.52? Let's check it out. Pi over 6. It is. So indeed, what this equation is telling me is that the angle of 30 degrees, or pi/6 radians, is the arcsine of 1/2. In other words, for this function, we can think of it from our unit circle perspective. We can also think of it from input-output perspective, right? If this is my sine inverse, I gave it an input of 1/2 as a length. So I know on my unit circle, when I have 1/2 as a length, I actually have two places where that could be. So let's be careful in our solution. 1/2, if my radius is 1, 1/2 is right here. So my y value is y equals 1/2 occurs right here, right? There are actually two solutions to this equation. So here, when I have an input of 1/2, my output is this angle of 30 degrees or pi/6. Likewise, I have an angle. Let's see, what else on my unit circle has a length of 1/2? Well, 5 pi/6, of course, 150 degrees. This angle here, 150 degrees, or 5 pi over 6, which has a y value of 1/2. So in this case, I can use multiple representations. Same with here. I can do a sine of x equals 0.5, looking from 0 to 2 pi, every pi halves, -1 to 1. And graphically, I can see that I should get two solutions. And I know those solutions are 30 degrees and 150 degrees, or pi/6 and 5 pi/6. You can always trace, I believe I'm in radian mode again, pi/6, that intersection point of 0.5, and also, let's see, 5 pi/6. All right, that's a lot of learning about inverses. Last but not least, our very last problem before you get to do some work on your own. In this last problem, it's asking, C, what is sine of x with another set of parentheses with a -1 on the outside? If x equals 1/2 degree. Let's see if that makes sense. This notation, when we think structurally, anything that's on the inside of the parentheses, this -1 means that you take 1 over, or the reciprocal of that. So in this case, sine of x raised to the -1 is 1 over sine of x, and when x equals 1/2 degree, which makes sense, 1/2 degree can be an input, we get 1 over sine of 1/2 degree, and we can compute that in degree mode. Mode, degree, quit, sine, 1 over sine of 0.5, which is 114.59, which should make sense because it's also 1 over, if we look at the solution in the first case, right, 1 over 0.009. Oops, why didn't that compute? Sine of, let's try that again. Those should be the opposites of one another. So let's do quit, whoops, mode, degree, sine of 0.5, 0.00087. I wonder if this is just a degree of rounding error. I rounded this to 0.009. What I'm looking for is 1 over that answer to match what I got down here. Ah, and indeed it does. Okay, that was just a rounding error. So I'm happy with those solutions. Excellent work. What you've been learning in this video with your tools are that inverse trig functions, meanings, notations, graphs, and calculations to solve equations and understand trig functions using this worksheet. Now your job is to practice. See the attached activity and handout. Good luck!